Okay, let's go ahead and start on point 6. This is the division section. Like I said, this section's a little bit rigorous. There are 3 test questions from this section, so as we get to them, I'll be sure and highlight them. But not quite as easy as multiplication, but not too bad either. So this was given earlier in the notes, but I just listed it again because I think sometimes students go, I don't know whether it's simplified or not. So this is how you can tell if a radical is simplified. So the radicand has no factor raised to a power greater than the index. So if we had cube root of x fourth, that can be simplified because the power of the radicand is greater than the power of the index. So those are things that we don't want. We can't have any powers higher underneath than out here. That means I can break this down into x cubed and x1, or x to the first, for instance. The radicand does not contain a fraction. So this would not be simplified if you have a fraction under the radical. And third, we can't have a radical in the denominator. So those are the 3 things that tell you you are not done. It is not simplified. So power is greater than the index, a fraction under the radical, or a radical in the denominator. And these are the 2 that we're going to address in this section. So we already know how to break this down, like I said, into x cubed times x to the first. Now we're going to learn how to get rid of fractions under radicals and how to get rid of radicals in the denominator. So here's some more examples of things that are not simplified. This one has a radical in the denominator. This one, oh, how funny, same one I picked. This one has a power higher than the index, and this one has a fraction under the radical. And here's a list of some that are considered simplified. The radical's only in the numerator, and the fraction is not under the radical. The power under the radical, x to the first, is less than the index. And on this fraction, the radical's only in the numerator. So it's okay to have a radical in the numerator. It's not okay to leave a radical in the denominator. So division is like multiplication. You can go back and forth and write it as a single fraction or split it up. For instance, if we had square root of 3/4, I would want to break that down into square root of 3 over square root of 4. And before I break it down, I always look to see if this can be simplified, and 3/4 can't. So I simplify first. If there's nothing to simplify, then I break it up. Square root 3 doesn't have any pairs, but square root 4 is 2 2's, which come out as a single 2. So keeping it under like that, it would not be obvious that this is the answer. But then there'll be times when, let me think of something. You have 2 separate radicals, and you go, oh, 8 and 2 have something in common. I'm going to write it as a single radical. 8 divided by 2 is 4, and then I can simplify. Square root of 4 is 2. So if nothing's common, it's best to have them as 2 separate radicals. If something's common, here there was a 2 common, put it under a single radical, simplify. 8 divided by 2 is 4, and then simplify your radical. So this is one of those, again, that goes both ways. So they showed it in 2 different steps, but if you put double arrows, that just means it goes both ways. You can go from 1 to 2 or 2 to 1, depending on your 2 cases. So let's look at some examples, see how we're going to use this. And you'll see your previous chapters are going to be really important here because we're going to be simplifying radicals. So you need to make sure you've done the homework for the sections previous to this so that you know how to simplify radicals and so on. So here is an example like I did above. Something is common, so this is the type where you would want to put it under a single radical, and then say 2 goes into 2 once. 16 divided by 2 is 8. So now it's simplified. Now I can do the cube root of each piece. The cube root of 1 is 1, because 1 times 1 times 1 is 1. The cube root of 8 is 2, because 2 times 2 times 2 is 2. And here's an example of one where there's nothing common, no common factors, so it is best to split it into 2 radicals. So the numerator turns into 3 and 5 x's. The denominator turns into 2 2's. Then you can see here I've circled the pairs. This one gets circled, this one gets circled, and so 2 x's come out. And then a pair here, which means that comes out as a single 2. So x times x is x squared. What do we have left under the radical? A 3 and an x. So x squared radical 3x over 2. So then I pause and say, is everything simplified? Do I have any powers here higher than the index? No. Do I have any radicals in the denominator? No. Can anything be simplified here? No. So we're good. So that's the kind of thing we're going to do using methods from your previous sections in this chapter to simplify and get rid of that radical in the denominator or the fraction under the radical. So let's use those techniques on these two. We'll do A together, then you should shut off your video and try B on your own, and then we can compare answers. So I look here and go 160 and 5. Do they have anything in common? Yes, they do. 5 goes into both of those, so I'm going to write it as one big radical, 160 over 5. Then I can take my calculator and see how many times 160 is divisible by 5, and that is 32. Remember that number 32? That's the one I told you to memorize. 32 is what? 5 2's. So now we can, and if you don't remember that on a test, it's no big deal. All you have to do is make a tree for it. But you see it so many times, it's really nice to have it memorized. So 1, 2, 3, 4, 5 2's. And remember, this is a square root, so we want to be circling pairs. So we have a pair of 2's here. We have a pair of 2's here. So that comes out as 2 times 2. So my answer would be 4 radical 2, because there's still a 2 underneath. So we use the division property of radicals to write it as a single radical. Then we use methods from the last chapter, from previous sections, not the last chapter, in order to simplify. Okay, so turn off your video, work on B on your own, and then come back and we'll compare answers. So 60 and 3 do have something in common, 3, so I'm going to write it as a single radical. So radical 60 over 3. 60 divided by 3 is 20. Now I have a nice simple problem from previous sections. That's 4 times 5, which would be 2 2's and a 5. And as we learned previously, any pairs under a square root come out as a single. So my answer would be 2 radical 5. Beautiful. So this is pretty fun, huh? Okay, let's go ahead and move on to page 2. Whoops, page 6. My screen looks a little blue. I wonder if I need some. There we go. That looks better. except I'm not up at the top. Okay, so we have some more to practice on. So notice 5 and 20 have something in common. So I should simplify that. So 5 goes into 5 once. 5 goes into 20 4 times. So that would leave me with, I'm going to split it up into separate radicals now that we have it simplified. Square root of x to the 4th over square root of 4. So I just simplified 5/20 into 1/4. Then I wrote it as separate radicals. 1x to the 4th is just x to the 4th. And 4, of course, is just 4. And then the beauty of this is they're both perfect squares. So 4 divided by 2 comes out as x squared. And the square root of 4 is just 2. Done. So if they could all be this simple, that would be nice, right? Okay, so go ahead and shut off the video and try D. D is very similar to the one we just did. Okay, 6 and 27 have 3 in common. So I need to divide both by 3. So 3 goes into 6 twice. 3 goes into 27 9 times. So now let's write it as 2 separate radicals. Whoops, I missed something else, didn't I? They have x's in common. So this is x to the 1st. Remember that little trick I showed you? Cross out the smaller x and take that many away from the larger x. So now I can see in the numerator all I have is square root 2. In the denominator I have 9x to the 4th. Under the square root. And also what you could do to simplify your fractions if you want. This was 6/27, you could go 6 fraction bar 27, hit enter, and the calculator simplifies it for you. So you can see that 2/9. But you still have to simplify your x's by hand. So this was x to the 1st, this was x to the 5th. We cross out the smaller base with its exponent, and because it's a quotient rule, we subtract the exponents. So x to the 4th is in the denominator, no x in the numerator. So square root 2 doesn't have any pairs, so it's going to remain square root 2. And then square root of 9x to the 4th, those are all perfect squares, right? This is 2 3's, which comes out as a single 3. And 4 divided by 2 means x squared is on the outside. Okay, now we have some that are a little trickier. Now they have numbers outside. But remember, that number outside just means multiplication. So when you see that, and because this is a fraction, when I go to rewrite this, I'm going to write it as 2 over 1. Then it's easier to multiply the fractions at the end, because 2 is really 2 over 1. So 3 and 8, nothing in common. X and y, nothing in common. So since nothing's in common, then we should break it up into 2 separate radicals. So square root of 3x to the 6th over, I said square root and I wrote cube root. It's supposed to be cube root of 3x to the 6th over cube root of 8y to the 9th. So now I have to look for simplifying. So I'm looking for exponents that are divisible by 3 or groups of 3. So this one's divisible by 3. 6 is divisible by 3. 8 is 3 2's, 2 times 2 times 2. And 9 is divisible by 3. So both of these are going to come out.